There are three main uses of percentages. Percentages can describe fractions, they can describe change, and they can be used to compare two different things. So we'll go through and look at examples of each of these different uses. First, percentages can describe fractions. So here's an example. An opinion poll finds that 35% of 1,069 people surveyed said that the president is doing a good job. How many said that the president is doing a good job? All right, so if you focus in on the percentage here, notice that this is describing a portion of a larger group of people that were surveyed. So to figure out exactly how many that is, we want to start paying attention to some keywords that are often used with percentages. And the one here is the word of, and the word of indicates multiplication. All right, so what we need to do is multiply, and we need to find 35% of 1,069 by multiplying 35% times 1,069. So if you have a calculator that multiplies with percents and has that key, you can enter your calculation just like this. Otherwise, we need the meaning of the percent sign, which means divide by 100. So this would be written either 35 divided by 100, or you could write that as 0.35. And then we multiply that by 1,069. That equals 374.15. But then back in the context of the problem, we're answering the question, how many people? So it would make sense to round to the nearest whole number. So we could say about 374 people. A second use of percentages is to describe change. Now we have two types of change. There's absolute change and relative. And absolute describes the actual increase or decrease from some sort of a reference value to a new value. Or you could say an initial value to a future value, or initial to new. So for absolute change, the units will always be whatever your values are. So we might be talking about a change in dollars or a change in people if it was population, but we don't actually use percentages to describe that absolute change unless the two things that are changing are percentages themselves. Okay, so if we had like an interest rate that increased from 1% to 5%, okay, then we might talk about the absolute change there. But relative change, this is the one that we can describe using percentages. And this is a comparison between the absolute change and the original reference value. Right, so you'll notice in this equation for relative change, the numerator of this fraction is new value minus reference value. And if you look back up, that's just absolute change. All right, and then we're comparing that to the reference value, so that's why we're writing a fraction, and then multiplying by 100% to write this as a percent. All right, so let's do an example. I think this will make more sense with some real numbers here. But let's look at example 2. During a 6-month period, Lunar Industries stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? All right, so the absolute change is the new value minus the reference value. Okay, so the price doubled from 7 to 14. So the new value is 14, right? And the reference value, or what we're referring back to, is the 7. All right, so the absolute change is $14 minus $7, and notice the units are in dollars. Okay, now the relative change, we want to see how large or how small that change is compared to the original price, which was $7. Right, so we'll make a fraction and we'll compare the absolute change of $7 to the reference price, which was, in this case, it also happens to be $7. Right? And that's going to give us 1. So we want to describe this in terms of percentages, and you can do that by multiplying by 100%. Okay, so we have 7 divided by 7 times 100%, which is 1 times 100%, which is 100%. So we can say two things here. We can say that the stock increased by $7, right? And that tells us an absolute amount that it increased, but it doesn't really give us any point of reference as to whether that's a large change or a small change. And it really depends on the context. I mean, if we had If we had a stock that was, worth $2,000, an increase of $7 isn't maybe that large. Whereas if we, let's say you're at a coffee shop, and if your coffee increases from $2 to $9, that's a much larger change in a sense, even though it's the same dollar amount of the change. All right, so the relative change is describing how big or how small that change is compared to what the price itself is. Right, so that's why we have this second comparison. And it would also be correct to say that the price increased by 100%. All right, so notice here, doubling is the same as increasing by 100%, and we'll talk about why that is in just a minute. Another example of absolute and relative change, let's do an example with population. So the estimated world population increased from 2.7 billion in 1953 to 7.5 billion in 2018. And let's describe those two types of change, absolute and relative, over this 65-year period. All right, so the absolute is the new minus the old, or the new minus the reference. All right, so it's the change over 65 years. So we want to take the 2018 number, which is 7.5 billion, and subtract 2.7 billion. All right, so the absolute change is 4.8 billion. And notice again, the units match whatever's in the problem. So this is people. Okay, so it's an absolute change in terms of people. The relative change, we're going to compare that absolute change, 4.8 billion, to the reference value, okay, which is the 1953 population. All right, so we're interested in how much it changed from 1953. Okay, so compare back to 2.7 billion. And then this gives us a fraction, so let's multiply by 100% to convert that to a percent. All right, and that's going to give us about 178%. So again, we can describe the change in two ways. We can say that the world population increased by 4.8 billion, and that's just a straight amount. And then if we wanted to describe how major or minor that change is, we can say that it increased by 178%. Now, change isn't always positive. We've looked at two examples where something increased, but we could also talk about a change that's a decrease. Right? So if we have a laptop computer that cost $1,000 3 years ago, and now it costs $300, we can still talk about absolute and relative change. All right, so the absolute change is the new minus the reference, so it's $300 minus 1,000. So notice it's not always the larger minus the smaller. Okay, so the absolute change is negative $700, and that's indicating a decrease. Okay, and then the relative would be the absolute change, negative $700, okay, divided by the reference amount, which was the initial one, or the old one, which was 1,000. Right, and then we'll multiply that by 100% to turn it into a percentage. Okay, and that's going to give negative 70%. All right, so in both cases, the negative is indicating a decrease. The price dropped by $700, and it also decreased by 70%. A third use of percentages is to compare two different things. Right, so we can talk about the difference between two things, and we can again describe an absolute difference or a relative difference. So the absolute difference, instead of describing a difference between maybe like an old population and a new or something like that, maybe we're trying to compare two different populations at the same time. So maybe we're comparing like the population of Canada and the United States, right? But maybe both of them are our current populations. So what we need to do then is just choose one of the values to be the thing that we're comparing, and the other to be the thing that we're comparing to. Right, so we're going to call the compared value the thing that we're comparing, and then the reference value is what it's in terms of or what we're comparing to. All right, and those can sometimes be interchangeable, so it just depends on the context and which comparison we want to make. All right, but the absolute difference is still just a subtraction. It's the difference between those two things. And then the relative difference is a percentage, and that's comparing that absolute difference back to whatever the reference value is. So here's an example. Recent data showed that California ranked first among the 50 states in average income at about $68,900 per person, and West Virginia ranked last at $46,600 per person. All right? So what we can do is compare either West Virginia to California or California to West Virginia. Right? And we can do so in either absolute or relative terms. All right, so let's tackle part A first. How much lower is average income in West Virginia than in California? So in this situation, we're comparing West Virginia to California. Right, so West Virginia is the compared value, right, and California is the reference value, the thing that we're comparing it to. All right, so then the absolute, so this is part A, the absolute difference, right, is the compared value minus the reference. So it's the West Virginia number, 46,600, minus the reference number, which is 68,900 for California. Okay, and that's going to give negative 22,300. All right, now we can see that West Virginia is lower, and if we're trying to describe how much lower, it makes sense that we would get a negative number. All right, so it's $22,300 lower. And then a relative difference here, we want to compare back to the reference value. All right, so we want to take that absolute difference, right, and compare back to the reference value, which was California's number. Okay, so 68,900, and then we'll multiply by 100% to make this a percent. Okay, and that's about negative 32.4%. All right, so we can say that West Virginia's average income is about 32.4% lower than California's. Now let's do the same thing in part B, but the difference now is that we're comparing California to West Virginia, so it's in terms of West Virginia. All right, so now California is the compared thing, and West Virginia is the reference thing. Okay, and now we're asking how much higher is the average income, so we should expect to get positive numbers this time. Right. So the absolute difference, well, we just need to switch those two values. All right, so this is going to be 68,900 minus 46,600, right? And we're going to get 22,300. Okay, so that makes sense. It's the same difference, just without a negative sign. Then the relative. All right, now we shouldn't necessarily expect to get the same fraction because we're going to be comparing to something different, a different reference point. Right, so the absolute change is still 22,300, but now we're comparing to West Virginia's average, which is 46,600, and then convert to a percent. Right, so now we're getting 47.9%. Right, so we can say that that California's income is either an absolute 22,300 higher than West Virginia's, or we can say that it's 47.9% higher than West Virginia. All right, so because the percentages for the relative differences are different here, you really need to be clear when you're stating your results which thing was the thing that you're comparing to and which was the thing that you were comparing. All right, so it would probably be better in this case, if we didn't have the instructions really clearly written out here in parts A and B, we would maybe make a complete sentence out of this percent, right, and say it's which one is higher than which one. Okay, let's talk about the word of versus either the phrase more than or less than. Right, so it does mean something different to say that the population is 200% of something else versus 200% more than. Right? And the difference is that of means multiply, and more than means addition. Okay? And then let's add in less than at the same time. So 200% less than means subtraction. Okay, so let's do an example. Let's say that you pay $40 for a meal in a restaurant. So maybe it's a nice meal, 2 people, let's say. All right, and then if you're talking to somebody, maybe a month later, you go out to the same place, and let's say that your bill is 200% of what it was the last time you ate there. All right, so these percentages are describing relative changes, not absolute amounts. So we need to actually figure out what the percentage is in terms of dollars in order to figure out what the new bill is. All right, so if the last bill was $40, right, then 200% of that would mean multiply $40 by 200%. Okay, so on a calculator you can do either multiply by 200% or move the decimal 2 places to the left and multiply by 2. Right, so 200% of 40 is $80. Right, and then your bill is 200% of 40, so your new bill in that case would be $80. Right, if you say that your new bill is 200% more than your old bill, right? Well, then 200%, we know that 200% of 40 is $80, right? But then more than would mean we have that in addition to the $40, right? So your new bill would be $40 plus an additional 200%, or an additional $80. Okay, so your new bill then would be $120. All right, and then in this context, this last scenario would not be possible, but 200% less than would mean you've got your original bill, which was $40, and then your new bill would be, we would subtract $80, okay, and that would be a negative $40, which of course does not make sense. Now there is a connection between the two, okay? If you know a percent of, you can always find what the percent more or less than is, all right, and vice versa. All right, so let's say that something doubles. Okay, so let's say it goes from $30 to $60. Okay, well then we can say 2 things. We can say that the new amount, 60, right, is 200% of 30. Okay, because if you multiply 30 by 200%, you get 60. Right? And then the more than, right, well, we know it's $30 more than, right? And then to find that relative change, okay, we look at the increase, the absolute increase of $30, and then we compare that back to the reference value, which is the original $30, and that gives us 1, which is 100%. Right? So it would also be correct to say that $60 is 100% more than 30. Right? So 1 is just describing just a straight multiplication thing. Doubling is the same as multiplying by 200%. Right? But the more than or less than is describing the change. So you actually have to find the difference between the new and the old, and then talk about a percent there. Here's another example. Let's say somebody named Carol earns 200% more than William. What is Carol's income as a percentage of William's? And then how many times as large as William's income is Carol's? All right, so let's look at this first question. What is Carol's income as a percentage of William's? Right, so let's call Carol C and William W. Right, so we want to know Carol's income is equal to what percentage, and let's call it P, what percentage, okay, of, which means multiply, what percentage of Williams. All right, so we have a couple ways to figure this out. We could choose some actual numbers, or we could use algebra and variables. Right, so let's do it both ways, and then you can take your pick as to which one of these you like more. Right, so let's we know that Carol's income is described in terms of Williams. She earns 200% more than he does. So let's pick a number for him, and let's say that William earns $40. Okay, and maybe it's per hour or something like that. That makes more sense, but we'll keep the numbers small for this example. Right, now Carol earns 200% more than William. Right, so we need to take William's income, and then we need to add, because more than means addition, so we need to add 200% of that to figure out what Carol's is. All right, so we already figured this out. 200% of $40 is $80. Right, so in this case, Carol would earn 120. Okay, so then what is Carol's income as a percentage of Williams? Right, meaning what do we need to multiply Williams by? And that's where we can get back up to this blue equation. Right, what do we need to multiply Williams by? What percentage? Okay, and I can call it P% or a question mark, right, in order to get Carol's, which is $120. Right, and if you didn't know this initially, I mean, you might be able to guess in this case, but what you could do is divide both sides of the equation by $40, and then that would help you find the missing percent. All right, so that would be 120 divided by 40, which would be 3, right? And that's 300%. Now there is a way to figure this out without choosing specific numbers, and this explores the general connection between more than and of. Right, so whenever you know a more than percent, okay, like 200%, we can always figure out what the of percentage is, right? So she earns 200 more than he does, right? So let's call his percent, well, in other words, she earns, not only does she earn 100% of William's salary, but then in addition to that, she also earns another 200% of his. Okay, so 100% of Williams plus an additional 200% more, right? And then if you add those together, you get 300%, right? So she earns 300% of his salary. So in general, if I just get rid of this 200 and replace it by a P, right, then to get from a more than to an of, right, it's always just 100% plus whatever the percent more is, okay, P for percent. So she earns 100 plus P% of his. And then if this were less than, you would just subtract, right? So if she earns 200% less than, okay, then you would just subtract, and you would subtract here. All right, now to answer the second question, how many times as large as Williams is Carol's? This is just the verbal way to say what percent of his is hers. Right, so once you have that it's 300% of his, then that just means 3 times as large. All right, here's one more example. A store is having a 25% off sale. How does an item's sale price compare to its original price? Right, so what we're really saying here in words is that the sale price, right, is 25% off, which means less than. Okay, so that's 25% less than the original price. Right, so that's one way to describe it, but we could also use a percentage that's of rather than less than. And let's take the shortcut and use the little general formula, which would be 100 minus whatever that percent off or percent less than is. Okay, so we could say the sale price is 100 minus 25%, right? Or the sale price is 75% of the original. And that's it. Okay, so to summarize, there are three uses for percentages. They can be used to describe fractions, to describe change, or to compare two different things. In the next video, we will talk about percent versus percentage. When you see that in writing, what does it mean? And then also solving percentage problems for unknown percents.